Hi everyone, in this particular video I am discussing the solution of a linear programming problem through the solver tool of Excel. So I have this linear programming problem right here which is showing you maximization of z and 13x1 plus 11x2, and there are certain constraints. The first constraint is of storage space and the second constraint is of raw material, third is of time. So and 13 and 11 are the revenues on two different products. So I am not discussing how to formulate a linear programming problem in this question here. So the problem is already been formulated. A mathematical linear programming model has already been constructed. Now we want to find out the solution of this particular model. So this is one stage further. That means after the construction of linear programming models, how to solve them. Since it is a two variable problem, it can also be solved graphically very easily. But let's pick up a solver tool of Excel. It's an inbuilt tool, and we'll use it to solve the linear programming model, which is written right here. So I have two variables. Both the variables are listed here, x1 and x2. And I have highlighted these two cells here in the yellow color, which is going to tell me the different values of x1 and x2. That means these could be the two cells that can be understood, that these here the value of x1 and x2 will appear in such a way that the overall value of z, which is the objective function, this is the objective function right here, objective function. So the overall value of objective function can be maximized. So this is exactly the problem. So we have to create a platform so that we can solve it through solver. So let's start. The first constraint is here, 4x1 plus 5x2 is less than equal to 1500. So, and this is the constraint of storage space when this original problem was converted into a linear programming model. So I need to see what is the coefficient of x1 here, 4. So I'm going to enter 4 here. What is the coefficient of x2 here? In the first constraint right here, it is 5. So I'm going to enter 5 here. Same way in second constraint, which is of raw material, it is 5 and 3. The two coefficients of x1 and x2 are 5 and 3. Then I don't need to look into the coefficient of the time constraint. They are 1 and 2 here, 1x1 plus 2x2. So I'm going to enter 1 and 2. So remember, I'm entering these particular coefficients in corresponding columns of x1 and x2. And if I look into the objective function, what is the total profit I'm making? 13 and 11 on two different products, type 1 and type 2. So I'm going to enter 13 here and 11 here. Now I'm going to set up the whole constraint, the left hand side of the whole constraint in one particular cell right here. So if you look into the formula, let me just widen this cell, and let me pull this particular problem here, and let me put a little wide angle to this so the entire formula is visible. So is equal to, so look at the first constraint, 4x1 plus 5x2. So I'm going to put the left hand side of the constraint here, 4 times x1, the value which is going to appear here, plus 5 times x2, which is going to appear here. And to ease out the things, I'm going to freeze these particular two values. F4 you can press, function F4 or F4, whatever works in your laptop or computer. So this is actually the left hand side of the first constraint, 4x1 plus 5x2. So it is absolutely clear. Now if I look into this second constraint, it will be 5x1 plus 3x2. Since I have already developed the formula here, I can simply pull it down. And you can highlight the formula in any cell. You can see it is working absolutely fine. It is actually 5 of x1 plus 3 of x2. If we go to the cell ahead, then it is actually 1x1 plus 2x2, 1x1 plus 2x2. And this is the profit function right here, which is again 13x1 plus 11x2. So in this cell my profit is going to appear, so I'm going to give it a little different color. This is where actually the value of z is going to appear, the objective function, whatever it is. And now let's see the right hand side of the constraint. The right hand side, it is less than or equal to 1500. This is 1575. This is less than or equal to 420. The constraints which are there, the right hand sides which are appearing here. Now that's it. The platform is ready to solve the problem. Now I'm going to go to data. Then I'm going to go to solver, and okay, it's already been filled. Let me check it. So the first thing is set the objective function. So objective function is right here. Now this is a maximization problem. I get this particular thing selected, maximization, by changing variable cells. So carefully select x1 and x2, and let me just clean it a little bit, and so that I can redo the things. I'm going to add the constraints. So if I look into the things, since now I can since all the signs are less than equal to, so in one go I can select all these three constraints, and all of them are less than equal to all these three right hand side values here. Now there are linear programming models in which some constraints are less than equal to, some have more than equal to sign, and some have equal to sign. So in that case I can't apply this method. I have to manually add them one by one. That means you enter one constraint, 0 is less than equal to 1500, then you add second constraint, this cell is less than equal to 1500, and all. So I'll do it one by one again. Let's do it one by one rather than doing it all together. So what otherwise you can do that particular thing also, which I have just done. So first constraint, this is less than equal to 1500. Now I'm to add the second one, 0, which is right here, less than equal to this 1575. Add the third constraint is again this cell, which is representing 1x1 plus 2x2 is less than equal to 420, and I click OK. So you look into the thing, all three constraints are right here. You can cross check them, and then here I carefully select simplex LP and then click on solve. So it's working. Just a minute. Yes, keep the solver solution. Okay, I got it. So here is the solution of the problem, which is exactly demonstrating that the company should manufacture 270 units of type 1 and 75 units of type 2, and this is going to be their maximum profit. Let me give it a currency. Okay, rupees 4. This is going to be their maximum profit. So the solution is x1 is 270 and x2 is 75, and maximum of z is, I'll write it this way, maximum of z is rupees 4335. So that's it. Now we'll check whether the solution is practically possible or not. Is it feasible or not? Can I apply it practically? Then in that case I have to check whether all the constraints are satisfied or not. So 1455 is less than 1500. So it is absolutely correct. It has a green signal. That means true. 1575 is again less than equal to 1575. It is also true. 420 is less than equal to 420. It is also true. So there could be a possibility that one of them is not true. So in that case, I will say that the solution is feasible. If all the constraints do not come true, that means if, let's say here I have 1600, then 1600 is not less than 1500, then it is false. Even if it is happening in one of the constraints, then the solution is non-feasible. That means it's a theoretical solution which practically cannot be applied. Thank you very much.